activity 1.7, we're going to investigate the function f of x equals 3 minus 2x. And first off, part A asks, what familiar function is this? Well, it's a linear function. Now, why is that important? Well, it's got the same slope at every point x, which is -2. And we're going to see how that plays out as we calculate some average rates of change. So we're going to calculate the average rate of change from 1 to 4 for our function, which is f of 4 minus f of 1 all over 4 minus 1. Now these are just our values from our function, so I'll calculate those pretty quick. So -5 minus f of 1 is 1 over 3. So -6 over 3, or -2. Probably isn't that big of a surprise because we said we had a constant slope of -2, hence the reason it's linear. Before we get to C, let's find the other average rates of change. So we were also asked to find an average rate of change from 3 to 7. So that's f of 7 minus f of 3 over 7 minus 3. F of 7 is -11. F of 3, if we plug 3 in, we get 3 minus 6, so -3, so minus a -3 over 4. So -8 over 2, over 4, excuse me. And once again, we get -2. Definite pattern emerging here. The average rate of change between 5 and 5 plus h. You might be able to guess what this is going to be, but we'll work through it. F of 5 plus h minus f of 5 all over 5 plus h minus 5. And what you'll see is this is basically our difference quotient. F of 5 plus h, we got 3 minus 2 times 5 plus h minus f of 5 is going to be -7. And 5 plus h minus 5 is just h. So let's distribute here. So 3 minus 10 minus 2h plus 7 all over h. 3 minus 10 is -7, plus 7 is 0, so those cancel each other out. The h's will cancel, and once again, we get left with -2. Again, not a surprise. We have a constant rate of change, so our average rate of change should be the same over every interval. Now let's use our limit definition to calculate f prime of 1. We have the limit as h goes to 0 of f of 1 plus h minus f of 1 all over h. Applying that to our function, we have 3 minus 2 times 1 plus h minus our f of 1, which is 1, all over h, and we're going to take the limit as h approaches 0. So we're going to be taking the limit as h goes to 0 of 3, now let's distribute, minus 2 minus 2h, and then we have a minus 1 all over h. So 3 minus 2 is 1, minus 1, so once again all those cancel, which allows us to cancel the h. The limit as h goes to 0 of -2 is exactly that, -2. And so what we're finding is not only is our average rate of change -2 everywhere, our instantaneous rate of change is -2 everywhere. And that makes sense for a linear function. It's got a constant rate of change, whether they're instantaneous or average. So real quickly, we can calculate f prime of 2. It's just -2. F prime of pi, again, just -2. F prime of negative square root of 2 is also -2. And we could do that without ever having calculated this, because we know that we have a linear function with a slope of -2. So it's got the same rate of change no matter what point we look at.